Okay, this is the last question 4 in the grade 12 geometry March 19th Saturday workshop that we're going to do, and let's do it. Here's 4.1 to 4.3 we're going to do in this part, and 4.4 we're going to save for another video. Now here we go. In the diagram, O is the center of the circle. PQRS is a cyclic quadrilateral, so those points fit right on the outside of the circle. AP, there's a tangent through P, okay? Right there, that's a tangent line. Okay, that's what's important. It's also OB is perpendicular to PR. Ooh, that's a perpendicular line from the center. That would get bisected. Maybe that's useful. You might be able to use it. They also say that PA is perpendicular. So they're telling you that that angle A is 90 degrees. They're saying this is a perpendicular bisector from the center. And so those two are 90 degrees. There's all the information. Now what we're going to do, we're going to try and prove first that triangle APS, I like to put a little bit of color on the outside of these things. So I'm looking at that triangle APS there, prove that it's similar to BRS, In fact, we're proving that those angles actually match up, that the angle where B is will be the same as where the angle where A is, that the angle where P is will be the angle where R is. Well, that's a kind of nice little hint there, okay? Now we're going to prove that these triangles are similar. That means we're going to prove that they have the same angles, they're the same shape. Okay, so let's get started. Well, we've got one angle here that A is 90 degrees and B1 and B2 is 90 degrees. It's given. So there's one of the angles found. And we only need one more angle. Once you've done two angles, you can say that the triangles are similar because the third angle has to be equal because of angles in a triangle. So let's see. Can we have another angle here? Well, that's a tangent. That's an angle. That's an angle between a tangent and a chord. And this angle up here is the angle that opens up to that same chord. So that angle P4 and R1 must be equal. Well, then we've done it. We've just gone and done it. We've got the whole thing here. If we've got the P4 is equal to P1, and we know that angle A is equal to B1, then we've matched up two angles, and we can say triangle APS is similar to triangle BRS. So this is from the memo. When you do this, it's good to state what triangles you're looking at. Name them in triangle APS and triangle BRS. Make that statement right at the beginning. That's good mathematical etiquette, so do that. Okay, now the next question, you're supposed to, only for 1 mark, that AP times ARS is equal to BR times PS. Well, then all you do is take AP, put it over BR. Because the triangles are similar, because those triangles are similar, we can just make that fraction. And there we go. We can say, let's take a look at that. Because we've got similar triangles, in fact, let's just bring it up there like that. We can just put the letters AP goes with BR. They're proportional because they're similar triangles. AP over BR equals PS over RS. Well, that's it. Why? Because they're similar triangles. And then we just cross multiply and we get the answer. That's why it's only 1 mark. Okay, the last question they want us to do here, well, in this video, is prove that P4 is equal to R2. Well, let's see if we can do this now. What order should we do this thing in? Well, one thing, I'm seeing this is 90 degrees and this is X. There's an X there. One thing I know is that this angle P opens up to a diameter, to a semicircle. So I think it's going to be useful, and I did this before I even knew what was going on, is that P2 is equal to 90 degrees because of angles on a semicircle. Angles on a semicircle. So that's the first thing. Now I'm looking at this thing and I'm thinking, oh, isn't this angle here, if that's the 90 and that's X, 180 minus 90 plus X, 180 minus 90 plus x. This angle here, S1, must be 90 minus x. It must be 90 minus x. Now, why is that useful? Because I want to get at this triangle and figure out what this angle here is. And that angle there is the exterior angle of a cyclic quad. So S1 is 90 minus x because of angles in a triangle, in triangle APS. But now we can get at Q1. Q1 is 90 minus x because of the exterior angle of cyclic quad PQRS. So that's 90 minus x. Well, there we go. We're just about to get it. Because if that's 90 and that's 90 minus x, the only thing this can be, R2, is x, because it's got to add up to 180 degrees. So you can go 180 minus these two added together, and you'll get x. You see, 90 plus 90 is 180, minus x plus x is 0. Hey, that adds up to 180. Or you can just work it out. 180 minus these two things added together will give you x. And there you got it. P4 equals x. And so that's angles sum in a triangle you would use for why R2 is equal to x. And that's it. The last question is 6 marks, and it'll take a bit more time, so I think we'll just stop it right there.